question 19. And question 19 right here states, if u dot v equals 0, then u equals 0 vector or v equals to the 0 vector. And this is actually false, because you don't need to. They don't need to be 0 in order for this to be 0. This is just if it's perpendicular, it equals 0. Solution false. This is false because the dot product is 0 if the vectors are perpendicular to each other, regardless if one is equal to 0 or not. Yeah, so for example, well, let's take a quick example. Let's just draw just a basic perpendicular setup here. Let's just say, or use our xy coordinates. So let's say we have a point, this vector here, right here, we'll call this u. And these are perpendicular to each other. So u is equal to, and this is 1, 0. Let's just do it in 2 dimensions. And then this one right here, this is v. This equals to 0, 1. So none of them are the 0 vector, and these are just perpendicular to each other. Thus, what we have is, well, u dot v equals to, this just equals to 1, 0 dot 0, 1. So we add these up, so we get a, well, we just multiply the components and we get a scalar. So 1 times 0 is 0, and then plus, well, 0 times 1 is 0. Yeah, so we just get 0. So in other words, we got the 0 right here. Yeah, so we got a 0, and none of these are the 0 vector. So u and v aren't 0 vectors, so then this is false right here. So put that in there. Alright, so now let's take a look at question 20, and this one states, if u cross v equals to 0, the 0 vector, then we have u equals to 0 vector, or v is equal to the 0 vector. And this is again, this solution is false, because if these are equal to 0, then that just means the vectors are parallel to each other. So this is false, because the cross product is equal to 0 if the vectors are parallel, regardless if any is 0 or not. So for example, if we have right here, so let's say we have if u is equal to 1, 1, 1, and yeah, we just do it, so let's say u equals that, and let's say v equals to, well, also 1, 1, 1. So they're both equals to the same thing. So in other words, we get u cross v, they both equal each other, and they're both parallel, and this equals to, well, this just equals 0. And yeah, we could just solve that. We don't even need to solve it, because again, it's pretty straightforward. We have already covered this in my earlier video. So right here, so cross product, two non-zero vectors a and b are parallel if and only if a cross b equals 0, and if they're equal to each other, that just is also 0, because they're just equal to each other. It's still parallel. So that is that. All right, and now let's take a look at question 21. So if u dot v is equal to 0 and u cross v is equal to 0, then u is equal to 0 vector, or v is equal to the 0 vector. And in this case, solution, this is true, and this is true because the dot product being 0, I'll just put erase this comma. Yeah, because the dot product being 0 means both vectors u and v are perpendicular to each other, so it's perpendicular. While the cross product being 0 means both vectors are parallel. So you can't have parallel vectors and perpendicular unless this is only the case if one of the vectors is 0. So you can't have u being so u dot v equals 0 means you're going to have basically perpendicular like this v, and then what we have is u cross v is equal to right here, this equals 0, so this means they're parallel. So u and v are parallel. So the only way you're going to have both of these is if that both of them are the 0, or at least one of them is a 0 vector. So in other words, you're going to have a u like this, and then you have the v vector is 0. Let's put that by itself like that. So v vector is 0. So in other words, it's perpendicular to it and parallel to it. So that's the only way you can have it. Yeah, or so put this like this, or you'll have u is the 0 vector, and then v is the non-zero vector. Yeah, so that's the only way you can have parallel and perpendicular is if you have one of them is just 0, if it's a special type. It just doesn't have any value there. Like that.